The diagonal of a TV set is 39 inches long. Its length is 21 inches more than the height. Find the dimensions of the TV set. Make sure to show your work to receive full credit. So on this question, let's draw the picture of the TV set. TV set is usually rectangular. And it says that the diagonal is from corner to corner, is 39 inches long. And the length is 21 inches more than the height. So we're going to say the height is x, and the length is 21 inches longer than that. That's x plus 21. And we can solve for x by using Pythagorean theorem. We get a right triangle here. So we can use Pythagorean theorem. We want to find the dimensions. The dimensions are going to be the length and the width, excuse me, the length and the height. So using Pythagorean theorem, these two sides are the legs, and 39 is the diagonal, and that's the hypotenuse. So we'll set up our equation as x squared plus x plus 21 squared plus, equals 39 squared. Pythagorean theorem is where you square the legs of the triangle and add them up, and that's going to equal the square of the hypotenuse. So we're going to clean this up a little bit to create a quadratic equation. X plus 21 squared is x plus 21 times x plus 21. Some people try to take a shortcut here and just apply the square to each individual term. That's not something that we're allowed to do because of this plus sign. So you have to write it out and FOIL it out. And then we have 39 squared. 39 squared is 1,521. We have x squared plus 21x plus 21x. 21 times 21 is 441 equals 1,521. Now we can combine like terms. We have x squared plus x squared, that's 2x squared. 21x plus 21x is 42x. We have a plus 441 equals 1,521. Let's subtract that on both sides. We have 2x squared plus 42x. And let's subtract those two like terms. That gives a negative 1,080. We have our quadratic equation, 2x squared plus 42x minus 1,080 equals 0. And I want to solve this by factoring. I'm going to start by factoring the greatest common factor of 2. That's x squared plus 21x minus 540. And so when I factor this, I've got to factor with 540, which is a pretty big number. So let's see if we can figure out factors of 540 that add to be 21. Factors of 540, 1 times 540, 2 times 270, 3 divides in there, 180. And remember, I'm looking for a pair that will get me 21. Right now, the numbers are really far apart, so that's not going to give me 21. 4 times 135, 5 times 108, 6 times 90, 7 doesn't divide. 8 doesn't divide. 9 does. 9 times 60. 10 times 54. 11 doesn't divide. 12 times 45. 13 doesn't divide. 14 doesn't. 15 does. 15 and 36, that might be it. 36 minus 15 is 21. So we're going to use 36 and 15, and we'll put the minus on the 15. We want the bigger number to be positive. Now we've got it factored, and we can set each factor equal to 0. X plus 36 equals 0. X minus 15 equals 0. We solve each one of these and get x equals negative 36 and x equals 15. And negative 1 doesn't make sense because we've let x be the height of the TV. So having a negative height doesn't make sense. So we're going to have a height of 15 with a length of x plus 21. That's 15 plus 21, and that's 36. So the dimensions of our TV are 15 by 36. Clara, the red graph, and Chris, the blue graph, are driving 2 separate cars to Lancaster. They begin the trip with a full gas tank. The amount of gas in gallons that remains in each car depends on the number of miles driven, as shown to the right. After how many miles will the tank contain the same amount of gas? If the number of miles driven is more than this, which car will have more gas in the tank? So let's take a look at this chart before we try to answer the questions. On the horizontal axis, we have miles driven. The miles driven starts at 0 and increases as we look to the right. If we look at this label here, we have gallons of gas in the tank. So at the very beginning, we have the starting amount of gallons as 60 in one, a little bit less than 60 in the other. So let's read the question again here. After how many miles will the tanks contain the same amount of gas? So the same amount of gas, we can see that we have a line in red for Clara. This is her miles driven and gas in the tank, and then we have the blue graph being Chris's gas in the tank and miles driven. And right here, the 2 lines cross each other. At that point where they cross each other, that means that the amount in the tank is the same as well as the miles driven is the same. So we want to know after how many miles will the tanks contain the same amount of gas. So the same amount of gas happens right here, and that happens at this mark in between 200 and 300, so we're going to say that's 250. So at 250 miles, the 2 cars have the same amount of gas. Now the second question says, if the number of miles is more than this, which car will have more gas in the tank? So when it says, if the number of miles is more than this, that's telling me to look to the right of that point. Remember, we had 250 is when the amount of gas is the same. More miles driven is going to be to the right of that. We want to know which car has more gas in the tank. Remember, our gas in the tank is this vertical axis, and we can see that the red graph is always above the blue graph on this side. So for this second half of the trip, the red graph has more gas than the blue graph, and so the red graph is Clara's car. Clara has more gas than Chris, so Clara's. Just on a side note, you can see at the beginning of the trip, when they've traveled less miles, the blue graph is on top. And so Chris started off with more gas, but it seems like his car has burns fuel faster. A certain radioactive isotope is the byproduct of some nuclear reactors. Due to an explosion, a nuclear reactor experiences a massive leak of this radioactive isotope. Fortunately, the isotope has a very short half-life of 5 days. Estimate the percentage of the original amount of the isotope released by the explosion that remains 2 days after the explosion. So this is an example where we're going to use exponential growth and decay. So let's write out the model for that. That's A of t equals A naught e to the kt. Let's make sure we know what these different parts stand for. Sometimes I write it instead of A of t, sometimes I write it A equals A naught e to the kt. A naught, that is your initial amount. So in this case, that would be the amount of the isotope that we start with. Then K is our either growth or decay rate. In this example, because it mentions having a half-life, the isotope is decaying, so it's a decay rate. T is time. In this case, the units are days, but it can be something different in other problems. It can be years, hours, minutes, seconds, whatever applies in the problem. And then we have A, or A of t, and that's going to be your amount remaining after some period of time. That's your amount after time. So we want to estimate the percentage of the original amount that's remaining 2 days after the explosion. In order for us to figure that out, we have to know A, the decay rate. We can figure out the decay rate with just this piece of information. This isotope has a half-life of 5 days. And with that information, we'll be able to solve for K, the decay rate. When we have a half-life, that's telling you the relationship between the starting and the ending amount. So the amount that you end with will be half of the amount that you start with. And that's going to happen over a period of 5 days. I'm going to substitute this information into the exponential decay formula. That's A equals A naught e to the kt. I'll substitute in for A, half of A naught, and I'll substitute in for T, 5. So we have 5K here. Now to solve this, I'll divide both sides by A naught. That gives e to the 5K equals 1/2. I'm going to take the natural log of both sides. Natural log and e are inverses of each other. So we get 5K on the right. I'll divide both sides by 5 to get K equals natural log of 1/2 over 5. So this is our decay rate. Now once we get the decay rate, we want to find the percentage of the original amount that remains after 2 days. So I'm going to use my formula again, A equals A naught e to the kt, and I'm going to substitute in that decay rate that I just found, a time of 2 days, and we'll work this math out, and that will be we'll turn it into a percent, and that will be the percentage that remains, the percentage of the original. We have A equals A naught e to the natural log of 1/2 over 5 times 2. And this is what we're going to plug in the calculator. Let's rewrite it. 2 natural log of 1/2 over 5. And let's type that in. We've got e So I did second and natural log to get that e to the x button. And then I'm going to do 2 natural log of 1/2 over 5. Made sure to close the parentheses on that natural log and hit enter. So we got 0.7578. 0.7578. So if we look at this expression that we've written out here, we're thinking of this as the percentage of the original amount and it equals the amount that we have now. So this is going to give us the percentage that remains of that original amount. So we want to take that 0.7578, move the decimal to the right 2 places to turn it into a percentage. We have 75.78%. We want to sketch the graph of y equals negative 1/2 x cubed by plotting points. And when we plot points, we're going to choose some x's and find the y's. The x's I choose will be -2, 0, 1, and 2. These are the x's that were given by my math lab. And we're going to substitute those into our equation. We get -1/2 times -2 cubed. We need to follow order of operations. When we simplify, apply the exponent first. We have negative 2 cubed being negative 8. And then if we multiply negative times negative, we'll get a positive, and half of 8 is 4. So we get the ordered pair negative 2, 4. Plot that. The next one, we'll substitute a 0 in. That's negative 1/2 times 0 cubed. 0 cubed is 0. 0 times 1/2. Negative 1/2 is 0. So we get 0, 0 as another ordered pair. For the next one, I substitute a 1. That's negative 1/2 times 1 cubed. Applying the cube first, 1 cubed is 1. Negative 1/2 times 1 is negative 1/2. So I'll plot 1 and negative 1/2. And then finally we have 2. Negative 1/2 times 2 cubed. 2 cubed is 8. Times negative 1/2 would be a negative 4. Negative times positive is a negative, and half of 8 is 4. So we have negative 4. 2 negative 4 is right here. And I'll connect these points to get the graph of y equals negative 1/2 x cubed. For this question, we want to graph the solution to the system of linear inequalities. That's x is greater than negative 3 and y is greater than or equal to 6. So when we graph a system of inequalities, we want to graph each individual inequality on the same coordinate plane. So let's start by graphing x is greater than negative 3. And you're going to graph it in two parts. The boundary, replace the inequality with an equal sign, and graph the equation x equals negative 3. You're either going to graph it with a solid line or a dashed line. The solid line means the boundary is included, and the dashed line means the boundary is not included. You can tell whether the boundary is included by looking at the inequality symbol. We have greater than. In that case, the boundary is not included, so we want to draw the boundary dashed. The line x equals negative 3 is a vertical line. I'll draw that vertical line dashed. And once I've drawn the boundary, then I want to figure out the shading. We're going to shade either the left of that line or the right of that line. And to decide which side we're going to shade, we pick a test point. Now, the rules with picking a test point is that you can pick any ordered pair you want as long as it doesn't show up on the boundary line. And most people like to choose 0, 0 as the test point. We substitute that test point into the inequality. That's 0 is greater than negative 3, and we get a true statement. Remember, we're looking for solutions. Solutions make the inequality true. So our test point is right here, 0, 0, and it came out true. So we want to shade the right side of the line because those are the solutions. If my test point would have come out false, I want to shade the other side of the line. Let's try the other inequality now. We have y is greater than or equal to 6. We start by graphing the boundary line. The boundary line is y equals 6. We're going to graph the boundary line as a solid line or a dashed line, and we can decide which one by looking at the inequality. Because that inequality symbol has the equal to, the boundary line is part of the solution, so we're going to graph it solid. We're going to graph a solid horizontal line at y equals 6. Then we're going to figure out the shading. We're going to shade either above or below the line, and we'll make that decision by choosing a test point. We can choose 0, 0 again as the test point because 0, 0 is not on the line. Substitute the test point into your inequality as 0 is greater than or equal to 6. 0 is not greater than or equal to 6. That's a false statement. So this time, my test point of 0, 0 came out false. So below this line is the false side, and the other side of the line is the true side. So we want to shade that true side, which is above the line. Now, when you guys do this in my math lab, you're only going to select this region right here that's shaded in both different colors, because a solution to a system are just ordered pairs that are solutions to both inequalities. So you're only going to select this one region here that they have in common. For this one, we want to determine the real solutions to the system of nonlinear equations. Our system is y equals x squared minus 9x minus 3, and y equals negative x squared minus 7x plus 9. Now, to solve this system, since I already have one equation solved for y, I'll use the substitution method. I'll substitute into the other y. This is going to give me the equation x squared minus 9x minus 3 equals negative x squared minus 7x plus 9. I'm going to collect all the terms onto the same side. I add x squared on both sides. I add 7x on both sides. And I'll subtract 9 on both sides. That will give me the equation 2x squared minus 2x minus 12 equals 0. I'll solve by factoring. Factor out a 2 from every term. That would give x squared minus x minus 6 equals 0. Have x and x. The factors of 6, 2, and 3 will give me the negative 1 in the middle, as long as I put a negative on the 3 and a positive on the 2. I'll set each factor equal to 0. And we get x equals negative 2 and x equals 3. So these are both x coordinates. The solution to a system will be ordered pairs with both x and y. So I need to substitute these x's in to one of the equations to get the y coordinate. So if x is equal to negative 2, y is negative 2 squared minus 9 times negative 2 minus 3. I chose to substitute into the first equation, but you could substitute in the second one and get the correct answer as well. Negative 2 squared is 4. Negative 9 times negative 2 is 18. 4 minus 3 is 1. 1 plus 18 is 19. So one of our solutions is negative 219. Do the same thing with the other one. we have x is equal to 3. That gives y equals 3 squared minus 9 times 3 minus 3. 3 squared is 9. 9 times 3 is 27. 9 minus 27 would be negative 18 minus 3, and that's negative 21. So our other solution would be 3, negative 21. We've got our two solutions to the system of nonlinear equations. For this example, we want to use the substitution method or the elimination method to solve the system. We have 2x minus y equals negative 1, and y equals negative 2x. In this example, I already have the second equation solved for y, which is the first step in the substitution method. So I'll use substitution, and I'm going to set or substitute negative 2x into this y here. I would give 2x minus negative 2x equals negative 1. That's 2x plus 2x equals negative 1. Combining like terms, we have 4x equals negative 1. I'll divide by 4 to get x equals negative 1/4. So we found the x-coordinate. I need to find the y-coordinate. I'll substitute this x into one of the equations to get y equals negative 2 times negative 1/4. That's a positive 2/4, which is reduced down to 1/2. So the solution to this system of linear equations is negative 1/2, negative 1/4, comma, positive 1/2. A certain radioactive isotope has leaked into a small stream. 100 days after the leak, 4% of the original amount of the substance remained. Determine the half-life of this radioactive isotope. So what we're going to do is use this information here about 4% of the original amount remaining at 100 days. We're going to use that information to find K, the decay rate. So in our formula, K looks something like this. A equals A naught e to the KT. So with this information right here, 4% remains at 100 days. 4% remains at a time of 100 days. This part where it says 4% remains is telling you the relationship between the starting amount and the ending amount. So the ending amount will be 4% of the starting amount. I'll substitute this into the formula and solve for K, the decay rate. So we have A equals A naught e to the KT. Substitute 4% remains, 4% of the original amount at a time of 100 days, so we get 100K. I'll divide both sides by A naught, and that gives 4% equals e to the 100K. I'll take the natural log of both sides. Natural log and e are inverses, they cancel, so we get 100K equals natural log 0.04. Divide by 100, and we have K equals natural log 0.04 over 100. So now we have K, the decay rate, and we're going to use that to find the half-life. The half-life is the amount of time it takes to decay to half of the starting amount. So that means the relationship between our ending amount and our starting amount is 1/2. So if I use that in my formula, A equals A naught e to the kt, I'll have half of the initial amount, and I'll substitute that k that we just found, natural log of 0.04 over 100, and I'm going to solve for that time, that missing time. I divide both sides by A naught, and they cancel. I have 1/2 e to the natural log, 1/2 equals e to the natural log of 0.04 over 100 t. I'll take the natural log of both sides. Natural log and e cancel each other out. I have natural log of 1/2 equals natural log 0.04 over 100 t. And I'm going to solve for t by multiplying by the reciprocal on both sides. So multiply by 100 over natural log 0.04. 100 over natural log 0.04. So that's going to cancel all these out, leave me with t on this side. I have 100 natural log of 1/2 over natural log 0.04. We're going to type that in our calculator. So in the calculator, we're going to do 100 natural log of 1/2 over natural log 0.04. We have 21.5338. We'll round that to the nearest day. So we have a half-life of 22 days. So get 22, half-life of 22 days. For this question, we want to classify the function as polynomial, rational, or root, and then find the domain. Write the domain in interval notation. Our function is g of t equals t plus 9 over t cubed plus t squared minus 20t. And we're going to classify this as a rational function. Rational functions are the ones where we have a variable in the denominator. So we do have that t in the denominator, so this is a rational function. When we're finding the domain of a rational function, we're looking for restricted values, and that's when your denominator is 0. It's restricted because division by 0 is undefined. So to look for those restricted values, we take the denominator, t cubed plus t squared minus 20t, and we set that equal to 0 because that's what's restricted. Division by 0 is undefined. It's not allowed, so we're looking for these numbers that are not allowed. Now this equation, t cubed plus t squared minus 20t equals 0, is a polynomial equation, and we're solving it using factoring. We start by factoring the greatest common factor. All of the terms have t. Factor t out, and that would be t squared plus t minus 20. And we want to try to factor more. T squared plus t minus 20. T times t is t squared. 5 times 4 is 20, and we want the 5 to be positive and the 4 to be negative, so we create that positive 1t in the middle. Once we have it factored completely, we'll set each factor equal to 0. And t equals 0 is already solved. T plus 5 equals 0 becomes t equals negative 5. T minus 4 equals 0 becomes t equals 4. And these are our restricted values, 0, negative 5, and 4. If we think of these on our number line, the values of negative 5, 0, and 4 are the numbers that are restricted. They are the numbers that have to be excluded from the domain. All of the numbers outside of those numbers are included in the domain. And we want to write all of those numbers in interval notation. So let's represent this interval here. This interval has a lower bound of negative infinity and an upper bound of negative 5. This interval has a lower bound of negative 5 and an upper bound of 0. This interval has a lower bound of 0 and an upper bound of 4. And this interval has a lower bound of 4 and an upper bound of infinity. I've used parentheses on all of these numbers because they are the restricted values. They are the values that we don't want as a part of the domain. So finishing out our interval notation, we're going to write negative infinity to negative 5, union negative 5 to 0, union with 0 to 4, union with 4 to infinity. So these are all the real numbers except for negative 5, 0, and 4. And we have the domain of our function. So this question is talking about increasing, decreasing, and constant. We're given this graph here, and we want to write down the intervals of increasing, decreasing, and constant. So I like to look at the big picture first and sort of label it before I write down the intervals. So as I go through this picture, you always go from left to right. So going from left to right, pay attention to the y values. They're increasing, then decreasing, then constant, increasing, and constant. So you're always going to trace the graph going from left to right and pay attention to the y values. So we have increasing on this section, decreasing on this section, constant, increasing, and constant. So when you write down your intervals, you're going to write down the x's. So this one has an arrow on the end, so it's going to be increasing starting at negative infinity, and we stop at this x value here, which is negative 8. We also have another section of increasing here, so let's use this x value, and can't see it there, let's see. Negative 3 to negative 2.1, negative 3 to negative 2.1. And then we have a section of decreasing. That section of decreasing goes from negative 8 to negative 6. So I'm using this point right here. And then we have some intervals of constant from this point, negative 6 to negative 3. And then this section right here starts at negative 2.1 and goes on forever. That's negative 2.1 to infinity. So for this question, we're looking for relative minimum and relative maximum. And there are two components of this, the x and the y coordinate. The y coordinate is the minimum or maximum, and the x coordinate is the location of that minimum and maximum. So in this question here, it says the function obtains a relative minimum at. That is our x coordinate. That is the x. So we want to find the minimum, and the minimum is this little dip in the graph here, and that's at this point here. So that's going to be the x of negative 1. And then here, the relative minimum value, that's referring to the y coordinate of that point, and that's going to be the negative 2. Then we've got it obtains a relative maximum at, that's referring to the x part. So we're looking for this point here where we have a peak in the graph, and that occurs at x equals negative 5. And then the relative maximum value, that will be the y part of that ordered pair, which is 7. On this question, we're going to use the graph on the right. It's a little bit hard to see, but we're going to use this graph on the right to answer these questions about evaluating combined functions. We have f plus g of 9, f minus g of negative 9, g times g of 9, and f over g of 9. So we've got f plus g of 9. I'm going to read this from the graph. And on the graph, we have the blue graph, which is the straight line, is g. And the line that comes to a cusp, the red one, that's f. So when we do this, we want to find f of 9, g of 9, and then add those results together. So let's see if I can visualize this. Here's where x is 9, and I'm going to go up to the graph, and it looks like the y values are at 3. So that would be 3 plus 3, which is 6. The next one is f minus g of negative 9. And we'll do f of negative 9, g of negative 9, and then subtract those two values. So looking on the graph here, where x is 9, we have a y of 1 and a y of 3. So the y is 3 on f and 1 on y, so 3 minus 1 is 2. Part C is g times g of 9, g times g of 9, and that's g of 9 times g of 9. Okay, just a moment ago, we found g of 9 to be 3, so that's 3 times 3, which is 9. And then the last one is our division, and we want to find f over g of 9. That's f of 9 over g of 9. We found earlier that f of 9 was 3 and that g of 9 was 3. So we can do 3 over 3, which is 1. Thank you for checking out my videos. Have a great day.